Factorization, then. This is where we get to use our Christmas tree. So for prime factorization, we use our factor tree. And we start our tree at the top with the wonderful angel, or the star, whatever you put on the top of your Christmas tree. This is the number that we begin with. And then we branch off. We decided 9 and 10, easiest two numbers to multiply together to get 90. Here is where I've seen a lot of you screw up. You think that 9 is prime. 9 is not prime. 3 times 3 equal 9. So we have to make 3 and 3. Now, Kathy made a good point that she likes to circle or make herself some presents, because isn't that what we're getting to is the presents? Isn't that the most important part of your tree? How many presents are under it for you or me? Okay, so if I get done with my tree, if I get to a prime number, I'm going to either circle it or square it. Well, because I'm the present kind of girl, I'm going to go squares because I like square boxes. They might mean jewelry.
True, very true.
Round boxes mean
Coal.
cheese.
Coal.
Coal.
Coal. All good. That's all good.
Okay, so I have boxed my things, my prime numbers. So when I list it as 90 equals 3 times 3 times 2 times 5. Mrs. Miller, how do I check my answer? Are you ready? Use a calculator and type the number 3, then type times, then type 3, then type 2 times, then type 2, then type 5 times, and then type 5. And your answer should be 90. Okay? The biggest error you made was not going to prime. So I saw a lot of these were 9 times 2 times 5. And that's wrong, because it's not prime. Does that make sense? So this is where you need to know what numbers are prime. How many of you are okay with your tree? Raise your hand if you feel okay with making the tree. Garrett, question? You're good? Can you participate with us then with the hand going up? Thanks. All right, so once I know prime factorization, then I can get into greatest common factors and least common factor, or least common multiples. All right, so least common multiple, LCM. What of our two things that we've learned are we going to use for this? Multiples or factors? What, KDB? Multiples. And how do we know that? Because it's an M and it's in the name, right? So we know that when we figure this stuff out, we're going to use the multiples, the multiplying of two numbers together. Okay? When we are looking for the least common, what we're actually answering is the smallest common number. My applied 2 was thinking least, meaning it doesn't occur very often. But when they say least common multiple, it's the smallest number. Okay? So here's the example. What we do is find the multiples of both numbers. Then we list the multiples that they both have. And then we find the one that's the smallest. Okay? So if we have 6 and 9, our multiples of 6 and 9. 0 times 6, 6 times 1, 6 times 2, 6 times 3, 6 times 4, blah, blah, blah. We could continue out. And then we do multiples of 9. 0 times 9, 1 times 9, 2 times 9. And we find that we have one that's in common with 6. It's the first one. So we know it's going to be the smallest. Does that make sense to everyone? So the very first one you find that they match, that's your answer. So you would write least common multiple of 6 and 9 is 18. If you don't do this, it's really hard to get this. So you've got to do your multiples to find the answer. Does that make sense? Finding the least common multiple. Remember, M, multiply. Right, Kelly? Does that help? How many of you are okay with least common multiples? Raise your hand if you're good there. Garrett? All right, now we're going to look at greatest common factor. So do you use factoring or multiples? We use factoring, right? We know we want to find our factors. So what we're looking for is factors that occur for two numbers that are common. And when we talk greatest, we want the largest number. All right, so the first step is to find the factors of each. So to take 48 divided by 1, 48 divided by 2, 48 divided by 3, 48 divided by 4, 48 divided by 6, 72 divided by 1, 2, 3, 4, 6, 8, 9, right? Then we list them just like we would if we were just finding the factors. And in one of your worksheets, they asked you to list all the ones they had in common. So the ones they have in common are 1, 2, 3, 4, 6. Mrs. Miller screwed up. Oh, these are the ones they have in common. 24. Which one is the largest number they have in common? 24, right? One of the questions that came up is they want to know greatest common factor, Mrs. Miller, and it's for 24 and 72. And it comes out to be 24. How can that be right? Isn't 24 a factor of itself? So yes, it is right. Does that make sense to everyone? Evan? No, ask.
No.
Why?
I figured it out.
Okay. Anybody have questions on least common multiple, greatest common factor? And the really, really funny thing to me is that you guys don't like to have to do the work part of it. Like, you just expect the answer to pop up. Right? Because you're like, Mrs. Miller, it should be easier than this. Okay? Here's what Mrs. Miller did last night. Because I was grading your worksheets. Are you ready? Here's one of your worksheets. See all my work? Yes, I had to go through and factor each number, just like you would have. So my question is, I get this worksheet back from you, and you know what I see? Answers. How did you do that? Did you do the work? Or did you guess and hope you got it right? Because it's pretty hard to factor unless you write it down somewhere. I can tell you this much. I cannot remember 124, 212, 3, 8, 4, and 6 when I start working on another number. And I'm pretty smart, but I am not that smart. Okay? The other thing you need to look for is if you've done it in a previous problem, there's no reason to repeat it. It's not going to change. Example. I factored 50 here. Do I need to factor 50 over here? No, I already have the factors there. So don't repeat work. Sometimes I would rewrite the work just so I had them next to each other, but I didn't have to repeat it. Does that make sense? This worksheet has been graded and is in the grade bucket for you to pick up. Its redo is due on Friday, the 10th. So is there questions before I send you on to your worksheets? None?